In section 1.2, modeling growth and decay, we will be looking at how to model using a recursive formula. Okay? And when we're working with growth and decay, both cases are going to be a geometric sequence. Which, just to remind you, means that our rule is going to be in the form u sub n equals r times u sub n minus 1. Or in other words, any term is the previous term multiplied by some common ratio. Now, we can determine what that r value is going to be based off the information we are given. We've got two cases. Either we're looking at growth, so something is increasing or appreciating, or we've got decay, which means something is decreasing or depreciating. Now, if we're looking at growth, our r value is going to be 1 plus p. If we're looking at decay, our r value is 1 minus p. Okay? And for both of those, our p value is just the percent increase or decrease as a decimal. Okay. So let's look at our first example here. Example A, we've got an automobile depreciating or losing value as it gets older. So we are supposing that a particular automobile loses 1/5 of its value each year. Okay, so that's going to be my P, 1/5, which if I find it as a decimal is 0.2. And we're writing a recursive formula to find the value of the car when it is 6 years old if it cost $23,999 when it was new. Now with these growth and decay problems, unlike the first section where we used the first term, the u sub 1, we're going to be using a zero term or a u sub 0 because no time has passed when we're talking about something new. So you might want to make a note to yourself up here that we're using u sub 0 for all of these. So in this particular problem, u sub 0 is $23,999. Now our rule is going to be u sub n equals, now we are depreciating, which means we're talking about a decay problem. So that's 1 minus our p-value, which we already found, as 0.2 times u sub n minus 1. Okay. Now we can take that a step further and simplify 1 minus 0.2 is 0.8 times u sub n minus 1. But you don't have to. Okay. And then we can use that information to find our sixth term. Okay. So you can either start with 23,999 and multiply it by 0.8 until you get to the sixth term, or you can type in this information in your calculator using your calculator shortcut, which, just to remind you, for this particular problem would be 0, 23,999. So my zero term was 23,999. And then always it's answer 1 plus 1. And then answer 2. And then whatever your rule is. And in this case our rule was multiplying by 0.8. Okay, and you can just hit enter until you get to the sixth year to get your answer. Right, go ahead and pause the video, and when you are done, hit play again so we can continue on to example B. Example B, we've got $2,000 in a bank account. So that right away I know that's my u sub 0. And it pays 7% annual interest. So that's going to be my p-value. But as a decimal, remember to go from percent to decimal, we move over twice. So 7 moved over twice is 0.07. Okay, and we get paid at the end of each year. And since we are talking about a bank account gaining money, this is growth. Okay? So our rule is going to be u sub 0 equals 2000, and u sub n equals 1 plus our p-value of 0.07 times u sub n minus 1. And once again, you can take that a step further and simplify it if you choose. That's 1.07 times u sub n minus 1. Okay. And you are looking for when that original deposit will double in value. Okay, so what you're looking for is your value being $4,000 or greater. So you're going to continue to, you can either use the calculator shortcut or just multiply each previous term by 1.07. But you are going to do that until you get to 4,000 or greater, and what you're looking for is how many years that takes. So whatever your term number is going to be the number of years. Okay. So go ahead, pause the video and finish that up, and then we can move on to the guided practice. I want you to try that on your own, and when you are ready to check your work, you can watch the next video.